looking here at solubility rules, and in particular, we're going to have a look at the impact they have on something called a precipitation reaction. So we'll have a quick look at it. Now, this one here is probably the more popular one that you'll see. You'll get this quite a lot within the classroom. Teachers probably do this mostly just because it looks quite nice. So the mixture of lead nitrate and potassium iodide, and both of these are colourless solutions. However, when you mix together, you get this colourless solution here, but you also get this bright yellow precipitate, and that's a solid. So precipitate is when you get a solid from two aqueous solutions. Now, we're going to have a look at how that happens and why that happens. So if we have a look at this equation here, what's actually going on is the lead and the potassium are swapping over. So it becomes lead iodide plus potassium nitrate. Okay, and this one here is going to be solid. So you'll notice there are state symbols here and here, and those are both aqueous, which means they're dissolved. Now, here, this one would be solid, and I can't rewrite it because you won't be able to read it that small, but this one would be solid, and this one would be aqueous. So what this yellow substance here is that's lead iodide solid, and the colourless solution is the potassium nitrate. However, it's not that simple, because it's not just that they swap over, it's a little bit more complicated. Now, this B here, just bear in mind that should be a lowercase b, that's a typo. But because this is in solution, when you dissolve ionic compounds, they separate. So actually, what you've got are 4 ions. You've got lead ion, a nitrate ion, a potassium ion, and an iodide ion. None of them are actually chemically bonded. They're all separate, they're all moving around on their own accord within the solution. Because the lead and the iodide are very attracted to each other, they will then bond together to form a solid, which will just leave these two. So when you actually do this, the reaction would look like PBI, which is a solid, plus K plus, which is aqueous, plus nitrate and NO3 minus, which is aqueous. Aqueous means dissolved. Now, what you'll notice is that actually the nitrate doesn't change. It's NO3 minus there and NO3 minus aqueous there. The potassium doesn't change. K plus aqueous there and K plus aqueous there. So actually, the only things that have changed here are these two. These are what we call spectator ions. So they're floating around and they don't really interfere with the reaction. They're just there. Right, a bit like supporters at a football game in a very simplistic manner. If they were not actually saying anything, they're watching, more like spectators on TV. They're not actually involved in the game, they're just watching it. They are there, but they're not actually involved. So what we actually do, we turn this into an ionic equation, and there is another video on ionic equations that you can have a look at, but the actual equation for this would be just this. So lead, which would be PB minus, P with a little b plus, so PB plus I gives you PBI. Now, why does this happen? So the reason this happens is because certain combinations of cations, these are my positive cations, and anions, my negative ions, certain combinations are very attracted to each other. And as a result, when they mix together, they become very attracted to each other, they stick together, and that makes them a solid. So in this case, we've got potassium and chloride here, which is another halide, so it's above iodine in the periodic table. It's more so, it's iodide would be less soluble than chloride in general, but they have very similar properties. So this one here is above 1. So if it's above 1, then it can dissolve. So potassium chloride or potassium iodide in this case can dissolve. Lead nitrate is above 1, so it can dissolve. However, the lead and the iodide, which would be slightly below 1 here, does not dissolve. So the solubility rating is less than 1, and therefore the solubility value is less than 1, so therefore it won't dissolve. The potassium nitrate, however, will. So this is what your precipitate is, and you can use this table to figure out and predict whether you will or will not get a precipitate. However, at GCSE, really what you need to remember are the rules. And these are the general rules, so it's worth just taking a note of these. Nitrates are pretty much all soluble. This one you don't have to worry about. Halides, so anything in group 7, are generally soluble. There are a couple of exceptions. Lead being one, silver being one, two quite important exceptions. Most soluble sulfates are soluble. Most carbonates are soluble, most hydroxides are insoluble. Don't worry about sulfide. And then the group 1s and ammonia are generally soluble as well, with some uncommon exceptions.